This is probably not the greatest thing I've ever done as a teacher, but I'm pretty tired and I'm trying to get this video up before you start working through it tomorrow. So I am going to just go through the answer key with you here and I'm going to talk through it. But I don't know why writing wears me down, but it does. So I'm going to talk through this answer key. Start plus change equals end. We are talking about U substitution in differential equations. So reminder that if you're trying to find a specific value, for example, you're trying to find S of 4 and they tell you S of 2. Start plus change equals end. That is going to be a huge, easy concept that we will come up time and time again. Okay, start of S of 2, you would integrate from 2 to 4 velocity, and that will tell you your ending position. For example here, a population of insects increases at a rate of that right there per day. Find the insect population after 3 days, assuming there are 35 insects at t equals 0. So what do we got? We have a rate. We are trying to find the amount, the population. So we are going to integrate the rate from 0 to 3, because I want to know how much after 3 days. So to do that, we integrate the rate from 0 to 3. Boom, boom, boom. That's the change plus our starting amount. We're going to start with 35. So start plus change equals our ending amount after 3 days. We'd have 682.340 insects. Usub, this is definitely something we need to spend some time on, but we'll look at it quickly here. Remember what Usub is. It is the opposite of chain rule. Okay, when you think of U substitution, it's the opposite of chain rule. If you see stuff inside of parentheses and you're trying to integrate, there's a pretty good chance that you're going to need it. Other clues that you're going to need U substitution: a complicated fraction, 2 different e's, a fancy exponent, and so on. Okay, you just kind of got to remind yourself of what it looks like. All right, so for example, I gave you something here, and we've got a complicated fraction. I've got an x squared plus 9 on bottom and this 4x on top. So we set x squared plus 9 to be u. The derivative is 2x. We got dx by itself, so we divided by 2x. Then remember, if we've got bounds, I had to change the bounds. So I took 0 and 3 and plug them into my original equation. That's what gave me 18 and 9. Then I substituted in. I got 18 and 9. The 4x that was on top didn't change. Okay, that stayed the same. Instead of x squared plus 9, I plugged in u times du over 2x, this guy right here. We plugged it in. The 4 and the 2 could reduce to just be 2. The x's are going to cancel like I want them to. And so then it's 2 over u, so that is the 2 natural log of u. I plugged in 18 and 9. A quick reminder that if we had something like natural log of 18 minus natural log of 9, you could write that as a division problem. And 18 divided by 9, oh yeah, that's 2. And remember, if we have a 2 in front, that really could become an exponent. That is the same thing as natural log of 4. That is a mean thing, but it is something they could do. Make sure you understand properties of logarithms. So for example here, we've got this problem right here. E to the negative 2x, sine of e to the negative 2x. I picked this as my u because it's fancy and it's inside of parentheses. Okay, it's the baby of the chain rule problem. So I made u this. The derivative e is what you see times the derivative of the exponent. I got dx by itself. Then I substituted in this e to the negative 2x. That stayed the same. That didn't change. This e to the negative 2x became the letter u. And then times du over negative 2 e to the negative 2x. If you did it right, the stuff is going to cancel. E to the negative 2x, e to the negative 2x. I'm left with this negative 2, so I pulled that out in front. Negative 1/2. And then I integrated sine. Well, the antiderivative sine is negative cosine. So that negative canceled out that negative in front. That's why it's positive. 1/2. Sine becomes cosine. We rewrite what u was, e to the negative 2x plus c. Remember, up here, we didn't have to plug back in our u because we had bounds. But if we don't have bounds, we do need to go ahead and substitute back in for u. A little bit confusing, but it's not the end of the world. Slope fields, I'm pretty good with slope fields. I'm not going to do an example. This is really why I didn't want to start from scratch, because I didn't want to do that slope field question. You can plug in numbers. You're very capable of it. Just don't screw it up. Particular solutions. So remember, particular solutions, we took the antiderivative. So I took the antiderivative of this guy, and I got this thing with a c. Well, since they told me that when I plug in pi, I get 1, I plugged in pi and tried to get 1. And that is going to allow me to figure out what c is. So when I plugged in here, I got -2 cosine of pi is -1, so that's 2. I subtracted 2. I got c is equal to -1. That's why this right here is my answer. The same thing I started with, but by plugging in what my c was in the end, gave me that. Last one. Oh man, this was much better to go without writing it in. At least for me. I apologize. I'm a bad person today. Separation of variables. Sikio, separate, integrate, solve for C, solve for Y, options. Remember, it could look lots of different ways. It could say find the particular solution. It might say solve the initial value problem. It might say solve this differential equation. Sometimes it just says separate the variables and integrate, but that's what we're doing here. You know what that looks like. Separate, integrate, solve for C, solve for Y, options. That's what we did here. First thing we did was separated. So we took this y and put it over here. We took this dx and put it over there. Separate. Then we're integrating. The antiderivative of y is add 1 to my exponent, divide by my new exponent. E3, ooh, this is a good one. 3e to the 2x. So 3e to the derivative of e is what you see. So is the antiderivative. But because I had that 2 right there, I had to divide by the derivative of that baby. Okay, because it was just a 2x, I had to divide by 2. Don't forget about that guy. And then it's plus c. Okay, separate, integrate. Now we're going to solve for c. So we're going to plug in 0 and 1. So 1 went right here, and 0 went right there. E to the 0 power is just 1. That's why this was just 3 halves. Minus 3 halves, it gave me -1. Once I figured that out, I plugged a c in. So I took c and plugged it back in right there. So it became 1/2 y squared. 3 halves, e to 2x minus 1. I did not like this 2 on bottom here, this 1/2, so I multiplied everything in the problem by 2, which gave me a significantly easier problem here. Then I got rid of the square. When I got rid of the square, it was the square root of that whole thing. And in the end, we had to decide, is it positive or negative? Sikio, this is our options. So we take 0, we plug it back in. If I plug in 0, I want to get a positive 1. Well, if I take a square root, it's always going to be positive. I want it to stay positive. That's why my answer is positive square root of 3e to the 2x minus 2. Some different stuff. You've done it not that long ago, so hopefully it's still somewhat fresh in your mind. Looks like Usub is going to be the one thing we're going to focus on, and we will at least do one day the week we come back from break over that, but that's going to be kind of our setup. Thanks, guys. Hopefully that helps. And if not, I'll see you in our live sessions.